Okay, page 568. Page 568. Topic of this section is trigonometry. 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 Is another name for triangle measure. And more importantly, in this section, we're going to be talking about trigonometry ratios. And trigonometry ratios are those related to angles and the sides of the triangle related to them. Trigonometry ratios are those related to angles, let's say angles, and the sides of the triangles related to them. When you're dealing with trigonomic or trigonometry ratios, and the shortened term or the abbreviation is trig ratios. Okay, so let's say we've got a triangle. And it's a right triangle. And we're going to name the vertices A, B, and C. When you're talking about trig ratios, the most important thing to understand are the three terms: hypotenuse, all right, the side opposite the 90 is always the hypotenuse. And then the two other super important terms are opposite and adjacent. Because your trig ratios are written using rules. And in the rules, they use the three terms when talking about a triangle and sides related to an angle. They use the three terms hypotenuse, opposite, and adjacent. Hypotenuse, opposite, and adjacent. And depending on which angle you're looking at, you have to understand the sides that are opposite and adjacent to the angle. Okay? So maybe next to opposite here, put across from. Adjacent right next to. Bless you. So let's get another triangle on your paper with a little more room around it. It's going to be a right triangle again, ABC. Now, in relation to angle A, you've got three sides in this triangle. All right? In relation to angle A to C is the hypotenuse. All right? And again, we're talking about angle A. In relation to angle A, side AB is called adjacent. Because it's next to the angle, isn't it? All right? It's next to the angle, so it's called adjacent. That side is adjacent to angle A. The hypotenuse is also adjacent to angle A. But the hypotenuse is always the hypotenuse. Okay? So side BC in relation to angle A is called opposite. Everybody see that? So let's get another triangle right here. And we're going to talk about angle B, or angle C, for a second. Alright, same triangle, ABC. It's a right triangle. We're going to talk about angle C right now. Sides in relation to angle C. Side AC is still the hypotenuse. Now, in relation to angle C, side BC is called adjacent. Because it's next to angle C. So the side that is opposite of angle C is side AB. And this has been the most confusing things for students as long as I've been teaching geometry, is I can't tell which one's opposite and which one's adjacent. There doesn't seem to be a problem identifying the hypotenuse because you've been doing that for a long time. Where the confusion comes is in relation to angle A. How do I know which side is opposite and which side is adjacent? So I've told people that if you can pretend that you're standing in this triangle and you have your back up against the vertex A, and you're looking out into the triangle, there is your opposite side. It's across from the angle. It's the opposite side of the angle. If you have your back up in here in vertex A, the side that's next to you is the adjacent side, as long as it's not the hypotenuse. The hypotenuse is the hypotenuse. Okay? Same with angle C over here. If you had your back up in this corner and you looked out into the triangle, whatever's opposite of you is the side that's opposite of C. Whatever is next to you that's not the hypotenuse is the adjacent side. Okay? So here's an acronym that you need to learn and be familiar with and understand. It's called Sohcahtoa. And what Sohcahtoa is the acronym for is the sine of an angle is equal to the opposite side over the hypotenuse. The sine of an angle equals the opposite side over the hypotenuse. The cosine of an angle is equal to the adjacent side over the hypotenuse. And the tangent of an angle. The tangent of an angle is equal to the opposite side over the adjacent side. Hopefully you see where the letters are coming from. The S-O-H, the so, sine, equals opposite over hypotenuse. Alright? In the ka, Sohcahtoa, the C is for cosine equals adjacent over hypotenuse. And in the Toa, the T is your tangent equals your opposite over your adjacent. Those are your three trig ratios. What you're going to be doing today is you're going to be given triangles, and you're just going to be writing the ratios and then doing the division for sine, cosine, and tangent of angles in a right triangle. So look at the top of page 569. Express each ratio as a fraction and as a decimal to the nearest hundredth. So you're going to need a calculator this week, and you're going to need a calculator that's got sine, cosine, and tangent on it. And sine, cosine, and tangent is abbreviated on the calculator sin, cos, and tan. It's 2 rows up from the 7, 8, and 9 on your calculator. Actually, it's 3 rows up. Alright? So given this triangle, QPR, and the side lengths 15, 17, and 8. You're asked for the sine, cosine, and tangent of P. Sine, cosine, and tangent of P. So I always write the acronym on the top of my paper, or write what I'm working with. Sohcahtoa. Alright, we're dealing with angle P first. So sine of angle P is equal to sine equals opposite over hypotenuse. In relation to angle P, the side that is opposite angle P is 15. And the hypotenuse of that triangle is 17. Your cosine of angle P. Cosine is equal to adjacent over hypotenuse. The adjacent side to angle P is the side that's next to it that's not the hypotenuse. So adjacent is 8, hypotenuse is still 17. And then your tangent of angle P. Tangent is equal to opposite over adjacent. So the side that's opposite of angle P is the 15 again. And the side that's adjacent to angle P is the 8. Those are your 3 trig ratios for angle P. The second part of the question was to put them in fraction form and as a decimal to the nearest hundredth. So that's 2 decimal places. So you take 15 and you divide it by 17. And you should get 0.88. Then you take 8 and you divide it by 17. 0.47. And then 15 divided by 8. And that is 1.88. That's your sine, your cosine, and your tangent of angle P in relation to that triangle. Any questions on those three ratios? All right, so let's do sine, cosine, tangent of angle Q. All right, sine of angle Q. Now we're looking at this angle up top. And sine is equal to opposite over hypotenuse. And the side that is opposite angle Q is 8 units long. And the hypotenuse is still 17. Cosine of angle Q. Cosine is equal to adjacent over hypotenuse. The side that is adjacent to Q is the side that's next to it. That's not the hypotenuse. So your adjacent is 15. Your hypotenuse is still 17. And then tangent of angle Q. That's equal to the side opposite the angle over the side adjacent to the angle. So opposite of Q would be 8. Adjacent to the angle would be 15. All right, and you haven't divided these yet. Let's see, how many of these do you have? You may have them all, where you don't have to put them in the calculator again. You got the 8 over 17, you got the 15 over 17. You got them all. So you can just transpose them. All right, your sine of Q is 8 divided by 17. You've already done it. It's 0.47. Your cosine of Q is 15 over 17, which is 0.88. And your tangent of Q is your 8 over 15, which is, you don't have that one yet, do you? 8 divided by 15, 0.53. Okay? Anybody have any questions about writing a sine, cosine, tangent ratios? Okay, your practice for today is going to be on page 573. Problems 1 through 6. And then 16 through 21. Okay, on a clean sheet of paper, the directions for the first 6: express each ratio as a fraction and a decimal to the nearest hundredth. On the second group of 6, find sine, cosine, tangent of J, find sine, cosine, tangent of L. Express as a fraction and as a decimal to the nearest hundredth. So it's what we just did. You've just got to do it for different triangles. Any questions?